Hi, this is Richard C. I'm a math tutor at Wyzant, answering a question submitted by a student. What we have is a formula here for the speed of a vehicle at any particular time t, when t is between 0 and 4, 0 being 6 in the morning, 4 being 10 in the morning. And they just want to know, when is this vehicle moving at its slowest rate? So what I'm going to do is just show you a nice little method that I use in Algebra 2. This is essentially an Algebra 2 problem. Let me just start by copying the equation here. So it's 30t minus 60 square root of t plus 70. And it's a little hard to see that this is a quadratic equation. Well, there's no square. You're thinking, what kind of a crazy tutor is this guy going to be here? And yeah, I might be a little crazy, but I think you'll agree that this method works well. We're just going to let a is going to be the square root of t. So now I can write y is equal to 30 a squared minus 60 a plus 70. And now you can see it's quadratic, a squared. And we know it opens up. I always like to have a little sketch here. Here's 4 here, 0 here is time here, and the speed here. Well, this thing starts at 70 when time is 0. We're at 70. You know that from looking up here or looking down here. If t is 0, a is 0. And we know it's a parabola. We know it's opening up because this coefficient is positive. So it's going to look, and you can never get slower than 0. So it's going to, my guess is that it's going to keep coming down, and then it's going to have a minimum somewhere, and then continue going back up again. And we're not seeing the left-hand arm of the parabola, but it is a parabola. So how do you find the minimum? Well, you can use calculus, but you don't need to. We just have to remember that x, the formula you're supposed to remember, is negative b over 2a. So I'm mixing my a's up here, but a in this case, well, negative b is 60. And we're trying to solve this. And 2 times 30 is 60. So this is when a is 1. Here are I shouldn't have used a, I guess, but the a here is 1. You're going to hit a minimum when a is 1. So we know it looks something like this now. So if a is 1, then square root of t is 1. If the square root of t is 1, then t itself is 1. So it's t equals 1, which would be 7 a.m. Okay. Now they want to know the speed, which is just the y value here. So the speed is just y equals, we know that t is 1, so it's going to be 30 minus 60 plus 70. So it's 100 minus 60, so it's going to be 40 here. 40. Miles per hour. And that's it. So we're just using Algebra 2 tools here. Nothing. We don't need calculus. If you wanted to use calculus, and the reason I'm bringing up calculus is the student that submitted this was thinking it was a calculus problem. If you want to use calculus, you can. You can take the first derivative here and set it to 0, and you could find the minimum point the same way. But it's not necessary. You can just use Algebra 2 here. And I think this is a good problem for the Algebra 2 students to work on. This little trick, if you want to call it a trick, of recognizing that it's a quadratic by just changing the variable from t to a here. That little trick comes up quite a bit in algebra. And so I think even if you're not interested in the rest of the problem, that little thing is something you might want to remember. Okay, that's it for this one. I hope it was helpful, and I'll see you next time. Bye-bye.